I'm Arsta Knudsen, and the technical lead of the Arquillian project. We're going to have a tour around the Arquillian Universe, and I'm going to be your guide. And the main topic, or it's going to be more about the getting real part than the BDD bit of it, but it's going to be some BDD in it as well. So within the Arquillian Universe, there's three core principles or laws of physics. The first one is that when it comes to testing, a test itself should be portable across all the environments that it's possible to run them on. We'll see more what we mean by that later. The test itself shouldn't necessarily be bound to where it's running. It's going to be bound to how it's going to run instead, or what it's testing. The second law is that we want it to be executable from both IDE and from the build system. We want you to stay within the flow you are when you're developing. You tend to be within the IDE. You shouldn't have to jump out of the IDE to run a whole bunch of build scripts, for instance, to get what you want done. But of course, you need the build tool support as well from being able to run it through, for instance, automated processes. And three, there's a whole bunch of things out in the existing universe or within the testing realm, and it's not about reinventing everything that's there. So we're going to reuse as much as possible that exists, but integrate it into one. There's a nice little quote when it comes to testing that we found on Twitter at some point. The purpose of automated testing is to enable change. Verifying the correctness is just a nice side effect. And it's the difference between writing something or writing a test while you're writing the code versus having the test there, and when you're changing something else to still verify that it's doing what it intended to do. So it's, in a sense, you're putting it down in stone that this is the expected behavior. So when you change things later, it still behaves the same. There is a testing gap now that is between the ones we normally hear about in the TDD space and so on. It's a unit test. It's a tiny little something of a unit that is pulled out of its construction, runs outside of where its intended environment, and tested in isolation, which is all fine in itself, but the full application that you're working with looks more like that. So how do you unit test that when you pull out the power, the skyscraper there is still fully lit? You can't really unit test that in a sense. You got to move over to the integration test to see that all the components in the whole line works. So when we set out to build Arquillian, which is targeting the integration space, we knew that we needed to be flexible in the sense that there's a lot of different technologies, a lot of different component models, different servers, different environments, both that exists now and will exist in the future, because the one thing that is constant is change, right? So we didn't want to hard-code it to one thing. In the same sense, we want to be extendable, so whatever we make doesn't necessarily fit your need 100%. We wanted to allow you to extend upon it or be able to experiment with new ideas of building in a testable universe. So Arquillian itself, in its core, comes with, or we're basically eating our own dog food. So it's built upon extensions, upon extension as well. The inner core is just a simple little event machine, which fires events, and you can observe them, similar to how the CDI eventing model works. People know CDI. And you have your producers and your ejection points and so on. So the test extensions adds an abstraction over or for firing test-related events. So you have like the before suite event, the before class event, before a test and after firing down again. And just Arquillian with a test extension, you have a common way of writing extensions for all the different test frameworks that can then build on top of that. So you can have test runners like JUnit, TestNG, or Spock, or JBehave, or Thucydides, and they just fire into the Arquillian event machine that now we're in this phase. And if you were to write an extension for that bit of it, you now don't have to consider how JUnit or TestNG or any of these frameworks work. You just know that there's specific events that you can hook into and do things with. On the other side, there is a container extension, which, similar to how the test extension work, it provides you with events for things like start a container, stop a container, do a deployment, or do a undeployment. So Arquillian with just the container extensions work like a container management system. And the container extension provides SPIs as well, so you can hook in any type of container in the background, going from JBoss, Glassfish, Yeti. But a container in itself is nothing more than something that can be started and something that can be stopped. While the project has been focused on the E side of things, doesn't mean that the abstraction is necessarily tied to that. It's just where we're coming from. So consider a container to be anything that's runnable or startable. And then there's an extension that binds those two together, allowing you to bind the test events to the container events. So when something happens, for instance, before class, do a deployment, or before suite, start up a container, for instance. So let's just have a look at how the basic of a test can look. I mean, that's a JUnit skeleton in itself. There is some class with some method that has an annotation test. And then you do an assertion on some object. The Arquillian version of that, so this is the JUnit integration, and it's specific to, or parts of it is specific to JUnit. So we're reusing the JUnit run with annotation, basically telling JUnit to hand over all the execution of the test over to Arquillian. We take over, and then we look for, in the before class phase, so before this class starts to run, we're looking for methods that is annotated with deployment. And that's your test scope, or your integration scope. That can be single components, or it could be full-blown applications. Of course, it could also be multiple deployment methods, so you can have multiple applications going to different containers, etc. And then we're reusing the specifications that are the component models that are under test. So in this case, it's a add inject, which is the 330 specification, and injecting back the live instance from the container into the test case. And you can go on to assert the state of that as if you were inside the container and you had your live object within your own components yourself. So looking at this, there's nothing that binds it to the container. So in a sense, anything that supports a web archive and add inject, this test can run with. So this is rule number 1, basically. Don't bind anything to the intended environment, of course, as long as the environment can support it. So let's see how this works. Oops. So in this example, we're actually mixing up a couple of different other extensions as well. It's not just the pure core. But what we want to do here, we have a JSF form that is being deployed in the application, part of the deployments method up here. it creates a JPA job archive that it has some JPI entities. And it adds a web archive, or it adds that to a web archive, which has the JSF pages. It has each of these stateless session bean to interact with the entity manager. And basically, it's a JSF form that can submit data and insert data into the database. But the way we want to test this is by first we're creating. So the conference is our JPI entity. We're currently on the client side, or within the IDE side of running. So we're creating a JPI entity, setting the values of it. Then we're navigating through Selenium to that form, adding that same data. Then we're doing something very funky down here, which is warping that call. So when you're pressing form submit in the excuse me, within the application, within Selenium, we're also sending along to say that, hey, you're going to execute this verify conference object with the conference that we have from the client side. You're going to verify that on the server side in the after servlet phase. So when the form is submitted and after that's done submitting, we have sent an object from the client side that is saying that we're going to verify something that's happening in this phase. And then that has, again, full support for the injections. So we can inject back the conference repository, which is the EGB, or the stateless session bean, and verify that the data actually coming from the database. So by not doing it like this, in theory, that your web page is returning the expected data doesn't necessarily mean that you have stored something in the database. It just means that the web page shows the data. In this case, we can actually verify that after the submit has done, we can verify that the data exists within the database, which is a different approach to it, or a different idea around it. So, how does this all work in the background? Let's look at how it's set up first. I mean, Arquillian itself is not bound to any dependency management system, though I will highly recommend using a dependency management system, just because Arquillian has dependencies, and the containers has dependencies, and extensions has dependencies, and bundling up those X number of dependencies manually can be painful. So if you look at a Maven example, first thing you do is just add a bill of material, as we call it, which is a overall POM that defines the different submodules in it and binds that to a specific version. Then you need the test integration, which is either JUnit or TestNG and Spock, and then you have that integration. And of course, you need the JUnit version that you want to run with as well. So as we were looking at the example, there's nothing here in the case that's binding it to a container. So how is that handled? Well, the first step when it starts up, we need to select some kind of container. And it can be multiple types of container. Either you're having a local container, embedded container that is running within the same JVM as your test case. It can be what we call a managed container, which is normally running on the same machine, but Arquillian can start and stop it. Or it can be a remote container, which just something Arquillian connects to. And a remote container could be still on your local machine, but it could also be a testing server, a production server, or the cloud somewhere. Arquillian doesn't really matter. It's just an IP that it connects to. And in the background, it's selecting the containers based on which adapters that are available on the class path. So to differentiate between the different environments in Maven, we tend to put up multiple different profiles, so you can specify whether you want to run this on your local box for development. For instance, if you have an embedded server, you want to run it there, or in the on the build server where you have a managed server or you have a test server that you're running against instead. So you can swap between the different modes of running. So then the second step is to start or connect to the server, depending on the adapter. And then we come into the packaging process. The first step here, which you saw the deployment method, that's a project called Shrink-Wrap. And it contains a couple of sub-projects again, which is deployment, resolver, and descriptors. So we, by using the Fluent API of Shrink-Wrap, you can bundle up different classes, you can bundle up different resources from the local class path for the file system, or wherever you get them from URLs. You can create the nested structure that is required to deploy your application, either as small as a single Java archive component, or as big as one or more enterprise archives. You can import them from zips, etc. And a resolver can handle integration with the Maven repository. So you can basically just say that, hey, I want to deploy a specific artifact. It will resolve it from the remote or the local repository and deploy that for you, potentially fetching the version information and so on from the POM, which it's running within. And then for the descriptor side of it, you have your different web XMLs, E2B, jar, application and archives, application XMLs, etc. Very useful in the case where you're testing multiple different configurations of something. Does my bean work under this type of security constraints, for instance? So instead of having to have X number of files on disk, you can specify them in the same type of Fluent API and just describe the different descriptors, and it will be generated on the fly. So when it's come to it's done with the packaging. This is a lot where both the internal Arquillian magic and the extensions magic happens. It will then deploy it to the container. And then when the test is inside the container, the test method is being run inside the container, so you have access to all the resources that the container provides. You can inject your beans, you can inject your EGBs, you can look up connection factories, you can send messages, you can read the database, you can log in as users and whatnot. It gives you flexibility to test in the same type of environment and the same programming style as the code that you're writing. And then through the test extension again, the result from the individual tests are being returned to the client, and based on the integration with the test framework, being JUnit or TestNG, etc., it will provide that framework with the results. So JUnit will pipe that out in the normal format that it would normally. So this works without any modifications, both from IDE and from Maven if you're running it through Surefire, for instance. And then the last step then is, of course, to undeploy it. And potentially stop or disconnect from the server. So what we saw in the demo earlier, there's the use of the enrichers, both to inject test-related resources, but also to inject your actual components. And that's part of where Arquillian is becoming a component model for test versus just being a test framework, where the extensions and Arquillian itself can provide you with specific test services to make your life easier and handle the life cycles of the different components. So different extensions have different interactions with with the core and how it feels from a user perspective. The first one is Arquillian does nothing and just... Oh, sorry, the opposite. Arquillian does everything, and you're running within the container, as we saw in the example. And the client side doesn't really exist beyond to trigger the run. The whole execution is moved to the container. One example of that is the Arquillian persistence extension, which operates on the data sources that are available within the application server or container. Basically a wrapper around the DB unit to allow you to annotate up the test method with oh, I'm blanking on the name. Use data set and some data set file, and then that will be inserted before the test runs, and should match a data file. So it both inserts data, and then your test can focus on what the actual logic of your test is supposed to be, and not on the inserting of that data. So you manipulate the data somehow, and then you have a data set that is supposed to be the result, and you can match that those two match, or that the expected result is there. Then the opposite of the in container is the run as client, where Arquillian does nothing and basically just deploys whatever you ask it to, and then it's running in the same JVM as the runner, as Eclipse or as Maven. And that's good for testing remote interfaces, for instance, or HTML pages, where doing JXRS calls from within the container to itself doesn't necessarily make any sense. You have a lot of protocols to go through, so you can stay on the client side and kind of poke at the remote endpoints, or remote EGBs for that matter. Example of that is Drone, which is the Selenium or any WebDriver type integrations, which will provide you with the testing services of Selenium, and inject you the Selenium driver. You can figure out which versions, potentially start the Selenium server, and give you the URLs to the deployment. And then the next one, the one that we actually saw in the example, is Warp, which combines both of them. So while the test is running on the client side, you can push over server-side objects to be executed within the life cycle of your application, to test behavior or manipulate the behavior, which is Warp. Manipulate behavior during the execution. If you need to produce, for instance, specific objects to create some specific states that can be difficult, or produce error conditions that are hard to do within the application itself. And supports both the servlet and JSF. So you can have after render, before render, and all the different servlet and JSF life cycles. So over to the topic of the talk, rather, or the BDD side of it, or ATDD. When you create when you set out to create a project for your own, you envision always something like that. There's the ultimate goal, and that's how you see the code, and that's how you feel it is. Some way along the path, it tends to end up somewhere in that pile of stuff. So there was a point of having that yellow thing on the side there that felt right when you made it, but not necessarily afterwards. And the key there is in the behavior, and in ATDD, it's about the requirements, right? You need the requirements. You're going to follow and produce code that satisfies the requirements, and not necessarily anything more. So it's similar to how TDD works, that you're going to implement something that satisfies the test and nothing beyond. Here you're going to implement something that satisfies that requirement and nothing else. And hopefully you're going to end up with that car. So in the BDD space, there's two runners or two different type of things that Arquillian work with. Is Spock. Anyone know or have used Spock? Cool. Anyone know about Thucydides? 1, 2. Good. And so I just learned how to pronounce Arquillian. Thucydides is short, can be said as 2 CDs. That's it. So let's go back to some demos and see what that could look like. So in a plain Spock example, you will have the setting up the driver yourself. You're hard coding some kind of URL to point to the application. Where that application exists, that's magic. But you get the more behavioral or executable specification style with the given when then language, and you can kind of write out more what the test actually is compared to what you would normally do in a in a unit test. And you're kind of closing up to the stakeholders level, but it's still quite low level from a stakeholders point of view. So that's the developer's version of BDD. And Spock with Arquillian. So both Spock and Thucydides and a lot of the other frameworks are missing what we think is a crucial part, and which is what we're trying to add. Both Selenium, Spock, and all of them, they assume that there's something there. They're focused on doing the WebDriver bit. They're focused on their testing framework or their style. Arquillian can add then on top of that to actually allow you to control the application deployment, to control the container and control the environment within the test itself without having to configure that on some other means. So the Spock version for Arquillian basically just add the deployment as we saw already. You can inject the URL which points to the web context that you deployed. You can inject the WebDriver that you can point to. Point to that URL, and beyond that, it works exactly the same as Spock would. We just added a layer of control to your environment. We can run that for the fun of it. Did a control F11, but basically left click and run as JUnit, or JUnit. And this is a simple application that has some bare advice, and it's a query language where you can query from country and strongest and cheapest. So if we look at the logs here, we had the JBoss application server that was up and running in the background, so we just connected to it. We can run that one more time, just to see. Where is? No. Run as JUnit test. Oh, there we go. So it's deploying the application. It's starting up the different beans, the database data being inserted, and they'd stop when it's done and undeployed. And that time we got an error. Cool. Anyway, so then let's look at Thucydides. Well, Thucydides adds is trying to aim at the acceptance test driven level more than the developer or the stakeholders level more than the developers level. So this is a JUnit version of Thucydides. Thucydides works with ECB and with JBehave and has somewhat different capabilities depending on the underlying implementation that you're or the test runner. But instead of running with the Arquillian one, as we saw before, we're running with the Thucydides runner, giving Thucydides control. We're telling Thucydides that this test case explains the story, the user story of searching for bears. It's nothing more than just a class, so something we can reference, something we can give a name, something we can categorize the things together. And then instead of using Arquillian Drone, it's using its own handler for dealing with the Selenium stuff, creating the web drivers and the pages. Anyone know page objects from Selenium? Right. The idea is to bundle in or to hide the complexity of dealing with or finding HTML, finding the elements and finding the values. Move that into an object so you have a Java abstraction to kind of work with it instead of having to, all over the test, replicate the same kind of expressions, and becomes fairly unmaintainable after a while. So it has a pages factories, and we have steps. So within the story, there's multiple steps, and the steps are meant to be high level because they're meant to be, or sorry, the tests are meant to be high level, so that from the stakeholder side and from the reporting side, you can actually see very much or understand what it's supposed to do without having to go into the details of how it's being done. So we're gonna find all the Swiss bears. That means we're gonna be on the main page, we're gonna search for from Switzerland, and we're assuming that that's gonna contain some bears. That's the whole test case from the stakeholder's point of view. But going into the steps, which is our reusable lower level, we can now start operating on the pages and the page factories and so on. And so we have a let's see, we have a page object here, which is the Bear Advisor page. And here we're starting to come into the details of how Selenium works. We want to clear the search box. We want to find the search box. We're going to input some text. We need to hack with some drivers because they don't completely work. And we want to extract the tables. By extracting the tables, we're trying to return the entities that we have. So now you have multiple layers of indirections, I guess, or abstractions. And you have an option to write down, to do acceptance test-driven development. It's the same as doing test-driven development in the sense that you start with a requirement, write up the requirement within some kind of code, and then you start to implement the different levels. So in the beginning, everything will be set up as a pending. So there's nothing that's implemented. And then as you go around and try to implement them and get them to running. I could execute that from the IDE as well, but the interesting part about Thucydides is the reporting bit. And all the steps and all of that is basically to get the reporting nice and to get the ability to from a stakeholder side, be able to see how this is supposed to work or understand the test. So we're running that with Maven, and yeah, see if we can. How well it starts up. So it's starting one. From Switzerland, and going through the different search requirements that we have for this application. and done. So now, let's see. Let's open up the reports. Of course, that starts on the wrong one. Oops. Ah. There. Okay, it's a bit. Come on. There you can see the whole thing, more or less. So if we go to the test results, the thing now is that from a stakeholder's point of view, you can see that we have set up the requirements for searching beers, and currently the implementation is 50% done, 25% is not implemented yet, and 25% of it is failing. So from a stakeholder's point of view, you can now really understand the process of how far you are along, and you can then drill down into the different steps, or the different stories, and see the individual steps. So the Belgium step works. And it's nicely also taking screenshots of the different pages within. Let me not put this in full screen. Different pages that happen during the execution. So it's easy for someone else, someone with non-technical skills, to go in and look to see how things look. Is this the way it's expected to be? And it's basically what we wanted. And you get out things like the assertions and the values of the different test criteria. Then we have the one that's failing. You also see why it's failing, and clearly stating there here. We are expecting to find a specific beer, but the web page itself has nothing. So. Integration between Arquillian and Thucydides is an ongoing process, and we're trying to get more integrated than what we currently are. There is a extensions for recording. For recording within Arquillian that goes beyond what Thucydides itself supports. So, as we saw with okay, I didn't enable that one. We're working on getting this into the Thucydides reports. So, on a story level, for instance, you can see the recording of what actually happened during that execution, and of course, it records both screens. So, this doesn't look quite good, but anyway. Someone can then come in and see what's been going on in the application during the night. Is it looking the way it's expected, and do we need some tweaks on the output from it? That's the failing one. And boom. So that's basically what I have to show you today. And if there's any questions along the way. Mm-hmm. steps is basically high level. The question is why the steps, I guess. Mostly for the reporting bit to show that the story has multiple sub-categories to it, and then to above the nitty-gritty details of how that is done. Will it work on all? To my knowledge, yes. I haven't tested it on all yet, but I would love to know if it doesn't work. And of course, we're at Arquillian.org, which is our main webpage. Oh. You can support the same thing as question. Which type of browsers can you support within it? It's using Selenium underneath, so it supports whatever Selenium supports. But that, or actually, it's not going beyond, but also supporting what the Source Lab on-demand services support. So you can hook it up to the Source Lab services, and they will execute it with all the different IDs. So you don't necessarily have to have them installed on your local machine. So you can get IE 5 to 10 or whatever it is with Android and with iPhone and all shebang.
What are the most important conceptual differences between Arquillian and Max Exam as they have been venturing into the main JE?
Good question. I don't know. I haven't looked at PaxSM for a long time. I know they were coming out of OSGI. Right. Is that coming through the OSGI Enterprise stuff, or?
I don't know very much myself.
Right. No idea. Sorry. I guess if they are going to Enterprise and we're going to OSGI, so we're kind of overlapping. Right. Right. No, I haven't looked at PaxSM in a while, so I honestly can't say. Oh, okay.
My question is like, when I execute the test in many containers without specifying many profiles, so like in one Maven build, I have it tested against, let's say, JBoss and non-hat, so that I don't have to configure like many builds. Let's say on Jenkins, otherwise I have to execute the builds many times with different, like -p and then different containers.
Yes and no. In Maven, you can't within one module, because Maven only resolves the class path once, and Arquillian currently doesn't do any class loading itself, so it relies upon whatever's on the application class path. And putting multiple containers on the same class path is going to guarantee you to blow up somewhere, because someone's depending on the same libraries in different versions, etc. But it can be done if you have multiple submodules, and you can import the test cases from one module, so you have multiple submodules with the container configurations. Or you can use Gradle, which is capable of actually resolving different class paths within the same run and run. Or if you have the same container adapter but different configurations, you can use multiple executions, because then you don't need to resolve or multiple surefire executions, because then you don't need to resolve the class path again. You just need to rerun it. But from a Jenkins point of view, I guess not using the Maven support, but using a batch script and doing a for loop over the different profiles or something could be. Right. Right. It depends on the adapter. If it's an embedded adapter like Glassfish Embedded, they will run in the same JVM. If it's a managed one, then it will be two separate JVMs. Both Glassfish Managed or JBoss Managed will start a different process when it runs. else? Or no? Well, thank you.